Where I'd put, if you were your folks, like a lot of your customers would be in the lead inspector, and even if they're doing environmental work, it's very similar, okay? Granite. I don't know if you've read where granite can give off some radiation, and I've been there once, and it's all granite. So, yeah, I wondered that myself, and that's what I was told. So I guess, but basically, the analogy I like to use is if you use this instrument constantly and used it properly, as we're going to learn today, you'd get more radiation moving from here to Denver in a year's time than using this, okay? And I don't see the people in Denver dropping like flies. Okay. Now, this is a scenario I don't really like to use, even though many of you may think you work 25-hour days, 400 days a year. Most of you don't. But to put this in better perspective, you see that it says that the exposure at the trigger, the hand holding the handle and at the trigger, is less than 0.1 millirem per hour, okay? Now, that's shooting into an alloy, a metal sample, okay? A higher density material. But let's say it was 0.1. That was the exposure at the hand. And you're the only operator, and you're going to run it 40 hours a week, 50 weeks a year. Your maximum exposure would be 200 millirems. And how much are we allowed on an extremity? Okay, 50 rems or 50,000 millirems. So you're a smidgen of what you're allowed, okay? Now, in lower density samples, the exposure at the hand goes up a little bit. Soils, it goes up a little. Soils, it's about 2 millirems, okay? But still, if you're the only operator for 2,000 hours a year, 4,000 millirems in a year, you're still well below the 50,000, very, very safe, okay? Different densities of sample scatter differently, okay? That's why I wanted to point that out. This is a good example of what not to do, okay? And if you did that, you'd have to do that for about 2 solid hours to reach that minimum that we were talking about of 50,000 on your fingers, okay? So we don't expect any of you to be doing that. But that's why you don't test things like that. That's why there's a test stand. So again, if you shot your torso, how many times you would have to do that, okay? Now, we have a lot of things. What do we do to keep the instrument safe? Well, a number of things. There are various warning lights. One, there's an LED here on the nose cone that will be blinking anytime that the X-rays are being emitted. That'll be blinking. In between tests, it will stay on steady, but no X-rays, only when it's blinking, okay? Also, the computer, which I have unplugged right now, I'm bumping it up, that will also be telling you a test is running, and you know X-rays are being emitted. And then we have a rear display, will be showing, it'll be counting seconds, and you'll know then, even if you can't see the first two things, you're holding it like that, you'll hear the screen will be telling you that X-rays are being emitted, okay? And other things are, we have a dual-purpose trigger, but it comes to you with a dead man trigger. Now, a dead man trigger means you have to squeeze and hold it the whole time. As soon as you let go, the X-rays are cut, okay? Now, that's really an artifact of the old isotope days. Isotope instruments had to have dead man trigger, okay? They couldn't bypass it. With a tube, we are allowed. So we have a dual-purpose trigger. We can set it up in a dead man or set it up in a touch-on, touch-off, okay? And it's really, we suggest one or the other depending on what you're doing. If you're shooting metal alloys, typical answers are 5 or 10 seconds at the most. You get your answer very quickly because it's high signal, high density material, you get a lot of signal. So we suggest, hey, the dead man is fine for that, okay? But you move into the environmental world and you're doing soils, a lot of the tests take 30 seconds, maybe even a minute, sometimes 2 minutes, depending on the element you're looking for and the level you're looking for, okay? So squeezing and holding that trigger for that length of time, unless you're trying to build your forearms up like Popeye, doesn't make a lot of sense. So we have it where you can click on, click off, okay? Now, what do we do to prevent accidents from happening there? Well, that's where you see that software proximity sensor. What that means is our instrument knows what air looks like, and it doesn't like it, okay? So if you accidentally pick the instrument up and it's not on a sample, so it's not